Let's continue through lesson 4.2. Now we have a new problem. This is example 3. I look at this, and once again I'm going to have you pause the video, brainstorm for a little bit about how you think you might be able to solve this, and then come back to see if you're correct. Okay, now the first thing I would notice about this one is it looks pretty different than the other ones. So since I've only got one exponential here, my first instinct would be to try to get that exponential by itself. So let's add 73 to both sides. So I have that. Now remember, I can't multiply those together because the exponent's attached to the 10. However, I can divide by that 5. And now I get to here. Now what I would notice pretty quickly is that I cannot do one-to-one property here. I'm not changing 73/5 to be a base of 10. That's not going to work. So, if I can't use one-to-one, what else can I do here? Well, we have talked about in class that if you have a single exponential or a single logarithm and you're stuck, try changing the form. See if that makes it look better. So instead of writing this in exponential form, let's change it to log form. Base stays the same. Input and output flip places. And here we go. Hey, that does help me out quite a bit, because now I just have to divide by -2, and that gives me my x value. So I can just take that, plug it into my calculator, and there we go. So if you have a single exponential and you cannot get one-to-one property work, then change the form and see if it looks better from there. Let's end on this one. This is a very, very different problem than any of the others that we've seen so far. Probably the trickiest. So pause the video for a little bit, maybe look through your notes to see if you can find something that looks like this, and then come back and we'll discuss it together. Okay, so if I look at this problem, the first thing I would notice is it looks an awful lot like a factoring problem. Like, if this was something squared and this was not something, like, kind of looks like a quadratic, u squared plus 3u minus 10. If this looks an awful lot like a quadratic problem, then let's use u substitution to factor it. So I'm going to say u is e to the x, so that makes u squared e to the 2x. Remember, to be able to use u substitution, we talked about this back in 2.1 or 2.2, you have to make sure that the thing is being doubled. So from e to the x to e to the 2x, we have to make sure it's being doubled. And that lets u substitution work. So because it is being doubled, I can change this e to the 2x to u squared. E to the x is u, and that looks way easier to factor. So now that I do that, I just need to multiply to -10, add to 3, so I've got a +5 and a -2. Now remember, the u substitution is only there to make the factoring easier to wrap our head around. Once you have it factored, you need to change u back to what it started as. So I know u was e to the x. So I'm going to change my u back now that I have everything factored. And now I can set each thing individually equal to 0. If you get a little stuck here, that's okay. We have a single exponential, can't use one-to-one property, so let's change the form. So this is going to be log base e, which is also ln. Input and output flip places. And I'm going to notice pretty quickly right here, remember I cannot plug a negative into a logarithm. That doesn't work. So that's going to go away. And I'm left with that as my answer. So that is our little introduction to solving some complicated exponential equations. In the next video, we'll look at an exponential story problem. And then we'll end the lesson with some graphing.